Force and pressure. Exercise page 22. Exercise Q 1.1 page 22. Write the word in the blank space. The SI unit of force is underscore 1. Dyne 2. Newton 3. Joule. Solution. The SI unit of force is Newton. Exercise Q 1.2 page 22. Write the word in the blank space. The air pressure on our body is equal to underscore pressure 1. Atmospheric 2. Sea bottom 3. Space. Solution. The air pressure on our body is equal to atmospheric pressure. Exercise Q 1.3 page 22. Write the word in the blank space. For a given object, the buoyant force in liquids of different underscore is underscore the same, density, different, area. Solution. For a given object, the buoyant force in liquids of different density is different. Exercise Q 1.4 page 22. Write the word in the blank space. The SI unit of pressure is underscore 1. nm3. 2. nm2. 3. kilogram per square meter. 4. Pa m2. Solution. The SI unit of pressure is nm2. Exercise Q2 page 22. Make a match. A group. B group 1. Fluid. A. Higher pressure 2. Blunt knife. B. Atmospheric pressure 3. Sharp needle. C. Specific gravity 4. Relative density. D. Lower pressure 5. Hectopascal. E. Same pressure in all directions. Solution. A group. Answers 1. Fluid. E. Same pressure in all directions 2. Blunt knife. D. Lower pressure 3. Sharp needle. A. Higher pressure 4. Relative density. C. Specific gravity 5. Hectopascal. B. Atmospheric pressure. Exercise Q 3.1 page 22. Answer the following question in brief. A plastic cube is released in water. Will its sink if come to the surface of water? Solution. The plastic cube is going to float on the surface of water as its density is less than that of water. Exercise Q 3.2 page 22. Answer the following question in brief. Why do the load-carrying heavy vehicles have large number of wheels? Solution. We know, pressure equals force area, so, greater the area of contact between two surfaces, lesser will be the pressure. So, the load-carrying heavy vehicles have large number of wheels so that the pressure on the road is reduced due to larger contact area. Also, using large number of wheels ensures that the force due to the load is shared among the tires and no single tire is under stress. Exercise Q 3.3 page 22. Answer the following question in brief. How much pressure do we carry on our heads? Why don't we feel it? Solution. We carry atmospheric pressure of about 105 pascals on our heads. We don't feel it because this atmospheric pressure is balanced by the pressure created by the air and blood inside our body. Exercise Q 4.1 page 22. Why does it happen? A ship dips to a larger depth in fresh water as compared to marine water. Solution. The density of marine water is more than the fresh water, due to which the buoyant force on the ship in marine water is more than the fresh water. Hence, the ship dips to a larger depth in fresh water as compared to marine water. Exercise Q 4.2 page 22. Why does it happen? Fruits can easily be cut with a sharp knife. Solution. Since the sharp-edged knife makes lesser contact with the fruits to be cut, thus the pressure exerted by it on the fruit is very large. Because of this large pressure, fruits are easily cut with a sharp knife. Exercise Q 4.3 page 22. Why does it happen? The wall of a dam is broad at its base. Solution. We know pressure of liquid increases with depth. So, the wall of a dam is made broader at its base so that it is able to withstand the heavy pressure exerted by the river water. Exercise Q 4.4 page 22. Why does it happen? If a stationary bus suddenly speeds up, passengers are thrown in the backward direction. Solution. If a stationary bus suddenly speeds up, passengers are thrown in the backward direction. This is because initially the whole body of a passenger inside the bus was in the state of rest. But, when the bus suddenly starts or speeds up, the lower half of the passenger's body comes in motion in the forward direction, but the upper half still remains at rest due to inertia of rest. Hence, the passengers are thrown backward when a stationary bus suddenly speeds up. Exercise Q5, page 22. Complete the following tables. Mass kilogram. Volume m3. Density kilogram per meter 3. 350. 175. 190. 4. Density of metal kilogram per meter 3. Density of water kilogram per meter 3. Relative density. 103. 5. 8.5 times 103. 103. Weight N. Area M2. Pressure Nm-2. 0.04. 20,000. 1,500. 500. Solution. We know, density equals mass volume. So, using above formula, we can find one quantity if other two quantities are given. Mass kilogram. Volume m3. Density kilogram per meter 3. 350. 175. 2. 760. 190. 4. So, using above formula, we can find one quantity if other two quantities are given. Density of metal kilogram per meter 3. Density of water kilogram per meter 3. Relative density. 5 times 103. 103. 5. 8.5 times 103. 103. 8.5. We know, pressure equals force area. So, using above formula, we can find one quantity if other two quantities are given. Weight N. Area M2. Pressure Nm-2. 800. 0.04. 20,000. 1,500. 500. 3. Exercise Q6, page 22. The density of a metal is 10.8 times 103 kilograms per cubic meter. Find the relative density of the metal. Solution. Given. Exercise Q7, page 22. Volume of an object is 20 cc and the mass in 50 grams. Density of water is 1 gram cm3. Will the object float on water or sink in water? Solution. Given. Exercise Q8, page 22. The volume of a plastic-covered sealed box is 350 cc and the box has a mass 500 grams. Will the box float on water or sink in water? What will be the mass of water displaced by the box? Solution. Given. Volume of box equals 350 cc. Mass of box equals 500 grams.